In this opportunity, please allow me to share my presentation titled Artificial Intelligence as Supporting Methods in Forensic Dental Identification. Before I go to the main discussion about this topic, please allow me to briefly introduce the Department of Forensic Odontology, Faculty of Dental Medicine, Universitas Airlangga. Faculty of Dental Medicine, Universitas Airlangga is located in Surabaya. This is the capital city of Jawa Timur, Indonesia. And the Department of Forensic Odontology in the Faculty of Dental Medicine, Universitas Airlangga is the first department of forensic odontology in university level in Indonesia. It was founded in 2012. Our department has 6 lecturers, including 1 professor, 2 staff with doctoral degree education, and 3 staff with master degree education. We have 3 main activities, including education, research, community empowerment, and social activities. These are some of our publications in the last 3 years, and our research topic are mainly about human identification, dental age estimation, sex determination, DNA analysis, forensic anthropology, and the development of forensic dental identification method. We also have some joint publication with the University Science Islam Malaysia during the last 3 years. And these are some of our community empowerment and social activities program. We got involved in the DVI operation on the Lion Air crash in Jakarta in 2018 and the Sriwijaya Air crash in 2021. Also, we give some training to the dentists about the management of dental record in 2021. We also give the education of personal identification record and disaster mitigation to the community in the disaster-prone area in Indonesia. So with this program, we hope that all community in the disaster-prone area will have their antemortem data. Okay, this is a brief introduction to our department. So let's move to the main topic of my presentation today. And I will start it from the introduction to forensic odontology. What is the definition of forensic odontology and what is the application of forensic odontology in human identification? I will discuss in this section. The principle of forensic identification and investigation was based on the fact that any action of an individual, and obviously the violent action constituting a crime, cannot occur without leaving a trace. And this principle or this concept was introduced by Edmond Lockhart, who also known as the father of forensic science. So, in other words, we can say that there is no perfect criminal action. We go to the definition of forensic odontology. With the most popular definition of forensic odontology was introduced by Kaiser Nelson in 1980. According to Kaiser Nelson, forensic odontology can be defined as the branch of dentistry that in the interest of justice deals with the proper handling and examination of dental evidence and proper evaluations and presentation of dental findings. Or we can also describe the forensic odontology as the combination of the science and art of dentistry and the legal system. From the definition above that I have mentioned in the previous slide, we know that forensic odontology involves these four aspects. The first is the management, then the examination, evaluation, and presentation of dental evidence to support justice and law enforcement. So this is the important aspect that we must understand when discussing about forensic identification or forensic odontology. Next, we need to know the importance of human identification. Why human identification is important in our life. There are some reasons of it in importance. The first, because it is correlated with human right consideration, both for living and deceased. Why? Because everyone in this world has the rights that attach with their self. So it must be fulfilled during their life and after their death. And the second, because it is as the part of the law enforcement. For example, in some criminal cases, the police need to know or must identify the victim first before they can start the investigation of the criminal case. The next, because human identification is correlated with religion, social, and cultural aspect. For the religion aspect, I think it is clear. We can take an example. For example, if the religion of someone is Islam, so after he or she death, so they must be treated as Muslim. And the social and cultural aspect, I will give an example in the next slide. The next, the importance of human identification because it is correlated with the monetary aspect, such as insurance, banking, pension, and many others aspects of monetary or financial. The next, because it is correlated with the merit status of someone, of a person. And the last, the human identification is important because it will relieve the sadness for the family members. Okay, this is the example of cultural tradition regarding funerals in Indonesia. This cave burial is practiced in Tanah Toraja, Indonesia. In this tradition, the dead person will place in the cave. After that, their family will make such kind of memorial balcony lined with carved wooden mannequin, which represent the deceased. Okay, we can understand that this cultural tradition can only be applied in that place, which means in Tanah Toraja in Indonesia. But this tradition cannot be practiced in another area in Indonesia because each area have their own tradition. And also, I think also it cannot be applied in Malaysia, this kind of funeral. This is the example of the importance of human identification correlated with the social and cultural aspect. We move to the human identifiers. According to the Interpol DVI Guide 2018, there are two types of human identifiers. that are the primary and the secondary identifiers. There are only three parameters of the primary identifiers. The first is DNA, the second is fingerprint, and also teeth. So there are only three primary identifiers. Apart from these three primary identifiers, we can categorize as the secondary identifiers, such as the ID card, driving license, medical record, or maybe the personal belonging and another information about a people. We can categorize as the secondary identifiers. In the field of forensic sciences, there are 5 commonly employed human identification methods. The first or the most common human identification method is visual identification. And the second is DNA analysis, then radiology or anthropology examination, then the fingerprint analysis and dental identification. From the mentioned identification method in the previous slide, we know that the basic principle of human identification is the comparison of two types of data that are the antemortem data and the postmortem data. The antemortem data we can describe as the data or the information about someone during their life, while the postmortem data can be defined as the data or information about someone after he or she is dead. We can get the antemortem data from the family, from the doctor, from the dentist, from the hospital, or another clinic that maybe the person or someone visit during his or her life. And the postmortem data, we can get the postmortem data from the examination of the dead body, from the autopsy process, such kind of that. Okay, we will continue our discussion about the artificial intelligence. After we know the forensic odontology, then we move to the artificial intelligence. Artificial intelligence, or AI, is widely defined as a tool encompassing any technique enabling computers to mimic human behavior and excel over human decision-making to solve complex tasks independently or with minimal human intervention. Hence, it's always concerned with a range of central problems, including environmental systems, intelligent transportation system, and the Earth system, and refers to a variety of tools and methods such as artificial neural network or ANN, genetic algorithm, fuzzy logic, and expert system. Or in other words, we can say that AI makes the machines that are programmed to perform certain tasks automatically without the need for human to supervise their work. According to Setan Kumar, a data scientist at Insedo Technologies, he said that there are many ways AI can be achieved. Some of them are machine learning, then natural language processing or NLP, expert system, vision, speech, planning, and robotics. I will briefly explain about machine learning. Machine learning is a type of AI that focus on building computer system capable of learning from data, enabling software to improve its performance over time. Machine learning algorithms are trained to find relationship and pattern in data using historical data as input to make prediction, classify information, cluster data point, reduce dimensionality, and even generate new contents. Recently in this time, we can take an example that we can easily generate such kind of Disney poster using AI. So we can say that machine learning or AI can generate new illustration or a new image according our prompt. This is the illustration of machine learning concept and classes according to a study by Muhammad et al. 2022. There are two concepts. The first is deep learning, and the second one is shallow machine learning. Machine learning shows good applicability when involving tasks related to high-dimensional data, such as classification, regression, and clustering. Moreover, it can improve reproducibility by learning from previous computation and extracting regularities from massive database. Therefore, machine learning algorithms have been widely applied in many areas, such as image classification, speech and image recognition, or natural language processing. The machine learning algorithms are classified into three types. The first is supervised learning, then the next is unsupervised learning, and the last one is reinforcement learning or RL. This is a comparison between all types of machine learning. I will try to explain one by one from supervised, unsupervised, and reinforced learning. The first, for the supervised learning, the machine learning is characterized by using label data set to train classification or prediction algorithm. As the model receives input data, its weights are adjusted until the model is appropriately fit. This step is included in the cross-validation process to ensure that the model doesn't over or underfit the data. The second type is unsupervised learning. It utilizes machine learning algorithm to analyze and cluster unlabeled dataset without human intervention. This algorithm uncover hidden pattern or data groupings. Hence, training data only contains the variable X to find unique structural information, such as group of elements with similar characteristics called clustering or data representation projected from a high-dimensional space into a lower one, known as dimensionally reduction. Then principal component analysis or PCA and singular value decomposition or SVD are two common techniques to reduce the number of features in a model. It is the best solution for recognizing image and pattern because it can find similarities and differences in the data. The last type is reinforcement learning. Unlike the other two types, this machine learning model experiences the process of achieving the goal by itself, using the principle of trial and error to maximize reward. To achieve the goal, the system's current state must be described. A goal must be stated and a list of permissible action and information on the environmental constraints that will affect the result of those actions must be provided. This machine learning model, I mean the reinforcement learning type, has been successfully implemented in closed world environment such as video game and applies to multi-agent systems such as electronic market. Next, after we know the forensic odontology and the artificial intelligence, I will move to the application of AI in forensic odontology. Okay. Forensic odontology may require a visual or clinical method during identification. Sometimes it may require forensic expert to refer to the existing technique to identify individual. For example, by using the atlas to estimate dental age, such as the London Atlas of Tooth Development. However, the existing technology can be a complicated procedure for a large-scale incident, requiring a more significant number of forensic identification, particularly during mass disaster, where there are many victims. This has driven many experts to perform automation in their current practice to improve efficiency. So in this part, I would like to briefly explain the application of AI in forensic dental identification. The potential of AI technology in forensic odontology can be categorized into four categories. The first, it is useful for human bite mark analysis. And the second, it is applicable for sex determination, then age estimation, and the fourth is dental comparison. This powerful tool can solve humanity problem by giving an adequate number of dataset. The appropriate implementation of algorithm architecture and the proper assignment of hyperparameters that enable the model to perform the prediction at a very high level of performance. I will move to the first application of AI in forensic odontology, that is for bite mark analysis. Bite mark analysis is an important aspect and is the most prevalent type of dental evidence presented in criminal court. Okay. The principle of bite mark analysis is find the best match between the bite mark wound and the suspect dentition characteristic. So matching bite mark to a suspect dentition involve examining and measuring a person's teeth. And also the principle of bite mark analysis is that there are no two mouths are alike. However, the use of machine learning method in human benchmark analysis, we can say it is still in the intermediate phase. Most previous method, from manual to semi-automatic to fully automatic approach, focus on computer vision system that utilize image processing algorithm. And one of the reasons why this field is not getting much attention from scholar and professional is the growing doubt about how accurate benchmark can be used as evidence in court. This is a study about the application of artificial intelligence for benchmark analysis. A study reported by Mahasanti Pia et al. In 2012, they reported the possibility of applying ANN in benchmark identification by using 34 specific features of benchmarks that were registered on pink wax. The experimental result saw a reasonable level of accuracy. However, further studies are needed in the feature selection process and the approaches and method for classification to improve the benchmark identification accuracy and to be able to work with incomplete benchmark images. While the higher level accuracy is obtained, computer-aided analysis is only aimed to eliminate the human bias as much as possible, and the manual analysis is still required. Okay, the second application of AI is used for sex determination. Sex determination is required when information about the disease is unavailable. In the case of accident, chemical and nuclear bomb explosion, natural disaster, crime investigation, and ethnic studies, determining an individual sex become the priority in the process of identification by a forensic investigator. There are several techniques for sex determination, including the odontological and anthropological approaches. Both methods, odontological and anthropological approach, include various metric and non-metric variable and biochemical analysis. Okay, since the automation trend in the medical field have been getting wide attention, computer science techniques such as machine learning, ANN, and deep learning are promising methods that can automate the conventional method and enhance its reproducibility. There are several studies that have been published using machine learning technique for sex determination. The first study from Koch et al. In 2017, Koch et al. Proposed a fully automated sex determination from individuals' maxillary dental casts. They use the ICP algorithm, and using the ICP algorithm, tooth models were aligned, and after the segmentation process, the model were transformed into depth image. The local discrete Gaussian transform, or DCT, was used in the process of feature extraction, and the random forest, or RF algorithm, was used for the process of classification. The classification was performed using 30 different seeds for random generator value and tenfold cross-validation. And the result, a value of 85.166% was obtained for average classification accuracy and a value of 91.75% for the area under the ROC curve. The next study about the application of AI in sex determination was conducted by Patil et al. A study using mandibular morphometric parameters that use digital panoramic radiograph has been proposed by Patil et al. In 2020. And then they use 7 morphometric parameters based on the previous studies for evaluation. A feed-forward neural network with a backpropagation algorithm was proposed in this study. Then, based on the 3 analyses done on morphometric parameters, ANN analysis had a higher overall accuracy of 75%. Then logistic regression and discriminant analysis, both of which had an overall accuracy of 69.9%. The next application of artificial intelligence in forensic odontology is about dental age estimation. Okay. The most common method of dental age estimation based on tooth development was introduced by Demirjian et al. In 1973 using the staging system. And Demirjian et al. Used digital panoramic radiograph to estimate an individual's chronological age based on the mineralization of 7 permanent left lower teeth. And this method is also suitable for determining dental maturity states, whether the individual with a known age is advanced or delayed, rather than predicting an unknown age. Extensive longitudinal studies in this field have influenced scholars and professionals to go beyond the conventional approach. A more sophisticated age estimation process can be done using computer science technique with less human intervention. And the automation process of age estimation proved to have exact reproducibility and be equally prominent, just like the conventional method. This is the study from the Tobel et al. About the application of AI for dental age estimation. The Tobel et al. In 2017 proposed an automated technique for age estimation based on the mandibular third molar development using panoramic radiograph. So they use the panoramic radiograph and they choose the third molar development parameters. By using the panoramic radiograph employed for the pattern recognition and classification approaches to the target images. First, the image contrast is normalized for all data, and ROI, which indicate the third molar, were cropped using the Adobe Photoshop software. Then a pre-trained model of the AlexNet network was adopted, and the performance was evaluated in a 5-fold cross-validation scenario using different validation metrics to obtain the accuracy, rank, and recognition rate, mean absolute difference, and linear kappa coefficient. As a result, the proposed method can stage lower third molar development according to the staging by human observers. But they suggest that more training is needed with data because this is the pilot study, and this pilot study was only done on 20 images. The next application of AI in forensic odontology was introduced by Milosevic et al. In 2022. This is a recent publication that utilized the largest panoramic dental X-ray dataset in forensic odontology. And this study was trained on deep neural network. This study aims to verify the deep neural network in solving its estimation problem. The authors successfully verified the literature for estimating the age of adult and senior subject by using one of the most extensive data set. And this, the finding of the study said that the novel method appears to be effective because the automated pilot approach used to stage the development of the lower third molar on panoramic radiograph resembles staging performed by human observers. The next application is about dental comparison. Okay, the establishment of an individual identity is an essential aspect in forensic identification. In a large-scale disaster, forensic teams challenged to perform effective and efficient identification by analyzing the available human identifiers. And the application of AI in forensic dental identification can help to achieve a more efficient and effective identification process. This is the application of AI in dental comparison. Choi et al. In 2022 conducted a study of the automatic detection of teeth and dental treatment pattern on panoramic radiograph using deep neural network. The detection of natural teeth and dental treatment was done by a pre-trained object detection network, which was CNN modified by efficient D3, and the study reported the outstanding performance of CNN in automatic detection of natural teeth. The accuracy is up to 99.1%. Or not the accuracy, the precision. The precision is up to 99.1%. And for the prosthesis, the precision is reached 80.6%. And the treat root canals, it is about 81.2%. And for the implants, it is the precision is 96.8%. This is the application of AI in dental comparison with the importance of forensic dental identification. Okay, the next we move to the important things that must be considered in a study about artificial intelligence. This is the ethical consideration in AI-driven forensic identification. The ethical considerations are fundamental in the development and application of AI-driven forensic identification system. Addressing this consideration is essential for promoting fairness, transparency, and accountability while leveraging the potential benefits of AI in forensic identification. By incorporating ethical frameworks and human oversight, it is possible to develop responsible AI systems that align with ethical principles and contribute to the advancement of forensic identification practice. In conclusion, in wrapping up our exploration of artificial intelligence as supporting method in forensic dental identification, we find ourselves at the nexus of technology and justice. The strides made in harnessing AI for forensic dentistry underscore a pivotal evolution in investigative methodologies. As we reflect on the efficiency, precision, and collaborative potential in wrapping up our exploration of artificial intelligence as supporting method in forensic dental identification, we find ourselves at the nexus of technology and justice. The strides made in harnessing AI for forensic dentistry underscore a pivotal evolution in investigative methodologies. As we reflect on the efficiency, precision, and collaborative potential that AI brings to forensic dental identification, it becomes evidence that we are witnessing the transformative era in the field. Looking ahead, the future of forensic dental identification is intrinsically linked with the responsible integration of artificial intelligence. Ethical consideration and privacy safeguard must accompany technological advancement, ensuring that the benefit of AI are realized without compromising the integrity and ethics of the forensic process. In closing, I extend my heartfelt appreciation to each participant for your thoughtful engagement. May this discussion be a catalyst for ongoing collaboration, ethical exploration, and advancement in the application of artificial intelligence within forensic dental identification. Thank you, and let us continue our journey toward a future where technology, expertise, and ethical consideration harmonize to strengthen the pursuit of truth and justice. Thank you very much for your kind attention. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.